So good afternoon. Thank you for making it this long. Okay, so I was the lucky one getting the last one. My name is Pedro Coutino. I'm a liquid crystal scientist working at Micron. We are located in Kent, Ohio, near Cleveland in the United States. And Micron offers solutions to light management problems by using liquid crystal technology. And today, I'm going to be talking about guest host liquid crystals used for augmented reality glasses. So this is the outline. First, I'm going to describe what is the ambient contrast problem that any augmented reality glasses is going to be facing, followed by the review of what are guest host liquid crystals. Then I'm going to provide the analysis of our E10 mode. And after that, I'll talk about a little bit of our manufacturing capabilities, and I'll finish with the conclusions. So augmented reality promises to be the next computing platform by blending the digital with the real world, but this has to be done in an ultra-compact and lightweight eyewear form factor. So the challenges are very complex, and one area is that you want to map the outside world in 3 dimensions. The second one is that you want to follow the user interactions, but at the same time, you want to project stereoscopic images of digital objects in front of the eyes, okay? So for this talk, I'm going to focus just on the last one. And an optical engine is composed of 3 main components: a microdisplay to generate the images, a magnifier that is going to make the image bigger and is going to project it into the retina, and a combiner. And the combiner is responsible to mix the outside world seen with the digital world projected into the eyes. And there are 2 main technologies nowadays, those that are diffractive-based as waveguides, and those reflective-based as partial mirrors. Both of these approaches are pretty good, but they face a fundamental problem. And the problem is that the brightness of the display is always competing with the brightness of the environment, okay? And this problem is very well known also for smartphones. But in a smartphone, you can just shove in a big battery and you make it, right? But for glasses, you have a lot of constraints. And one of those is weight and power. So a diffractive waveguide has an efficiency of less than 10%. That means that 90% of the photons are lost. A reflective one, 50%, okay? And a quantity that is very important to determine the overall quality of the device is what is defined as the ambient contrast ratio. And this quantity basically takes into account the transmission of the combiner, the brightness of the environment, and the brightness of the display. And it is very well known that you need an ACR of at least 3 to have recognizable images. Everything above is good. And just looking at that relation, let's say that the combiner has 100% transmission, or very close, right? And in that case, the brightness at the outside is going to overcome quickly the brightness of the display. So people start using like some neutral density filters in front. And let's say we use a 60% transmission filter. In that case, inside an office for a waveguide, the ACR is going to be 3, which is pretty good. But you walk outside, and that number drops to 1 immediately. Okay, so now you won't be able to see the images. Now, if we test it with a 10% transmission filter, like very dark sunglasses, outside, you get the ACR of 3, but inside, which is going to be higher, but you don't want to be walking with sunglasses in indoors, right? So this image here shows 3 different AR hardwares. The first 2, the Magic Leap and the HoloLens, those are diffractive-based. And the third one is reflective-based. And as we can see, indoors, the image is clear, the colors are vivid, and your AR experience is pretty good. You can really you can manipulate objects on demand. But as soon as you walk outside, you can clearly see that the image washes out, okay? So now the brightness gets compromised, and you cannot keep cranking the brightness of the display. So that's a problem. So there is always a need to